So now we want to look at some examples of how to find the derivative at a point using this definition of the derivative. So let's look at one, again, that we've already seen. So let's look at the function f of x equals x squared at x equals 1. Okay. So we already saw that the derivative at this point should be 2. So how would we use the and we did that really by approximating based on the graph. So how would we now do that using the actual definition of the derivative? So we would say that f prime of 1 is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. Okay, so this is using, just scroll up here, this definition right here, right? The slope of the tangent line at that point. And you, of course, you could just find the derivative function at this point and then plug in 1. That would be fine too. But I just want to look at a more direct approach first. Okay, so again, for all of these, if you do direct substitution, you're going to get 0 over 0. So let's go ahead and try to simplify this. So f of 1 plus h is going to be 1 plus h squared. F of 1 is 1 squared over h. So 1 plus h squared, that's going to be 1 plus 2h plus h squared. 1 squared is just 1. Okay, so these cancel. And I forgot my limit here. Make sure to bring that limit along with us. So this is the limit as h approaches 0 of h squared plus 2h over h. So now everything has an h in it, so we can factor out an h and cancel an h out. So in other words, we'd kind of end up like this, right? Where 1h cancels out of everything. So a lot of these types of problems, you're really just doing a lot of algebra, right? To solve these limits here. So this is the limit as h approaches 0 of h plus 2. And now we can do direct substitution to get just 2, right? 0 plus 2. And this is what we found that it was before. So this makes sense. Okay, so let's do another example here, one that we haven't seen before. So some of these are going to be harder to do than others because some of them won't lend themselves well to limits and this kind of manipulation with algebra. But let's just go ahead and try the derivative of f of x equals, let's say the square root of x at x equals, let's say 4. Okay. And for all of these, you might benefit from just kind of looking at the graph. And let me get rid of all of this and just kind of looking at what that function, what it looks like the slope of the function should be at that point, right? So just to make sure your answer makes sense. So if we look at the graph of x squared at x equals 4, and it doesn't matter at all what the output is, right? The output here is 2, of course, but that doesn't matter. We're looking at the slope here. So it looks not very steep. I would expect it to be like less than 1, right? Somewhere between 0 and 1 because it looks pretty flat. It's not perfectly flat, right? Perfectly flat would imply the derivative is 0. But, this point, I would just say it would be somewhere probably less than 1, somewhere between 0 and 1. So let's go ahead and see if that's true or not. So f prime of 4, let me write that this is an example. F prime of 4 equals the limit as h approaches 0 of 4 plus h, f of 4 plus h, right? F of 4 plus h is going to be the square root of 4 plus h minus the square root of 4 over h. Okay. Now this is just 2. Let me just go ahead and replace that with a 2 so I don't need to recopy this entire line just to write that part out. So if you remember how we would approach a limit like this, we would multiply by the conjugate in order to kind of make something happen with that square root. Okay. So these were all covered in Math Tools 1. If you didn't take that course, there will be a link to a playlist of all the videos in that course that are hosted on YouTube as well, if you want to review any of those. So anyway, so we can go ahead now and look at what this would be. So the reason we do this, of course, is because we now have the difference of squares. So this is the square root of 4 plus h squared, meaning 4 plus h, minus 2 squared, which is 4, over h. So now these are gone. And sorry, there should also be the square root of 4 plus h plus 2 down here as well. So now we have the limit as h approaches 0 of h over h, square root of 4 plus h plus 2. H is cancel out here, so we just have a 1 up here. And now we can take the limit as h goes to 0. So this will be 0. We'll have the square root of 4, which is 2, plus 2. So we're going to get 1 over 4. Okay, so the derivative is 1/4. So looking back at the graph here, we can say that the slope at this point would be 1/4. Okay, there is actually a one of the one of the examples on this site is for derivatives. So we can go ahead and look at that. If I just go ahead and change this to the square root of x, then you can see it does give us a graph of the derivative function. So we didn't actually look at finding the function for this one, but this is what it would be. So at 4, we should get 1/4, which is exactly what we get. So you can see, you can find that if you define f on this graphing calculator, you can define the derivative just with that d over dx notation. I'm not sure if it would work. I haven't tried it myself with the f prime notation. Let's try it right now. It works as well. So you can use the f prime notation. There you go. Okay,